Okay, let's move forward with our next speaker, Jovan Milovanovic. He's a co-founder and the software engineer at Finspot. This talk for today is reserved for the bronze partners for this year's conference. Finspot have significantly contributed to achieving everything we envisioned, so thank you. And this is another milestone in our long-standing collaboration, and we hope there will be many more. Jovan introduces Heartbeat, and the tool leverages transactional data and machine learning to provide real-time insights into companies' financial health. By combining daily transaction data with traditional finances, Finspot transforms how businesses are analyzed, and his session offers a fresh perspective on understanding company performance. Welcome.
Thank you. Can you hear me? Okay. Test. Okay. Okay, I'm Jovan. I'm one of the founders of Finspot. We are a fintech lender, which means that we essentially serve to help SMEs get funded real quick. This is a huge problem all over the globe, basically, but it's especially emphasized in our region. And the way we do it is through invoice financing. Maybe some people already know what invoice financing is. We essentially purchase companies' undue invoices, thereby freeing up their cash flow when they need it. So just very quickly about our history. So we've served around 200 clients so far, around 950 counterparties, so on the other side of transaction. Disbursed more than 30 million euros and processed more than 6,000 invoices. So we have a pretty good insight into how SMEs function, what are their issues, and what are their needs essentially. But today I would like to pay attention to the way these companies are analyzed. So and always I like to start the story with how we got to the idea of actually addressing the analysis of the SMEs, from ranging from more traditional approach in terms of assessing their yearly balance sheets, income statements, things like that, to a much more up-to-date stuff. So in December 2020, we started our lending operations, just kicking things off. A couple of months down the line, a year and a half maybe, we built a solid portfolio, 120 clients. We developed a lot of technology around it. We thought we were the smartest people in the market, right? And disbursed more than 50 million euros, which was a great success for us. But in September 2022, there was this one client which was, assessed that got the perfect score, which was deemed very financially stable. They had very strong financials. They did a lot of business with a lot of big buyers. Everything seemed fine. A number of large banks actually had big exposure towards this company, and we all lost money. So banks lost around 1.5 million euros. We lost around 40,000. Then we turned, back to the blackboard and basically looked inwards and said, okay, what have we missed? Why couldn't we foresee this? This was such an obvious default. And when we did a much more deeper dive, we saw that this company actually went bust 2 months before it was officially announced. And this was essentially like in one line what was wrong with it, and that is the traditional financial reporting is not a good fit for assessing small and medium companies. If there are finance people here in the audience, I'm sure you already know this, and a couple of reasons for that. Financial statements, year-end financial statements represent a state at the moment in time. Much more real-time insight is needed for these companies, and the reason for that is that they live in a very rapidly changing environment. So a year-on-year change for an SME is vastly different from a year-on-year change in a corporate, so a bigger client. and they also have a room for manipulation. So they can basically, you know, when they're small, they can adjust things however they want. This leads to two things. Defaults that can be preventable, and in my personal opinion, much bigger one, which is a missed opportunity, which means that banks essentially do not take into account all companies, any company that's below 2 years of maturity, right? So if they do not have 2 years of year-end financial statement, they will not analyze them. This is counterintuitive because, you know, how many companies do you know that are actually very solid companies even after a year of operation and that cannot get a loan for expanding their operation? This is where this huge gap is stemming from. So 5 trillion globally, just in our region the estimates are around 100 billion, but I think it's much more than that. So what was the next step? Obviously, as we are a tech, we have a very solid tech team in our company. So we developed a tool which we call Heartbeat. And in one line, it is a tool that parses these daily transactions and produces as close to real time as possible insight into the financial health of the company. So why did we look towards bank statements or daily transactions or cash flow, whatever you want to call it? Because we saw that they have very neat properties. So one, they offer you close to real-time insight. So whatever happened 2 hours ago is basically already recorded. They are globally available in every market, in every economy. They're available. So it offers you an ability to scale, and they're consistent across jurisdiction with some caveats, but the thing is that you can basically extract who made the payment to whom and on what ground, right? So these features provide you with, if you think about it, these are the building elements of what is finally represented in the balance sheet and income statement at the end of the year. So if you were to successfully process this and gain an insight, then you would be ahead of everybody else. So version 1 was because we didn't have access to lots of this data, but we have a lot of clients that use our services towards which lend to basically. So we created a version 1 software which loads and parses this data. And what is meant by data here, these are end-of-day bank statements that these companies generate. So we would jump on a call with them and say, okay, now while I'm watching, download 6 months of data and send it to me so that they cannot manipulate. So this would be easily solvable in the EU or any country that basically has access to open banking. But this is how we did a version 1. Then we apply some heuristics. So we know what usually triggers these SMEs to go bust or to commit a fraud or things like that, and then we act on it. I'm going to give you an example, which is essentially the company that I mentioned in the first slide. This is a very seasonal business, which means they do a lot of business in summer months, in the first half of the year, and then they basically don't do anything useful for the end of the year, and they defaulted in October 2022. So I'm going to show you a visual representation of some indicators. So this actually provides you with an insight into their just income and outcome. So how much money they receive, how much money they spend. So this is July of 2021. And this is their income level. July of 2022, they basically more than, I think, less than half of what they had in a year prior. So this is the first indicator, very visual example. These are their loans. So when I say loans, I mean how they repay their loans. So you can see that this is what you would normally expect, right? So you have a monthly installment, you pay it, then you move to next month. Then the line goes down, which means basically you either repaid portion of the loan or, you know, just didn't have enough money. But, you know, it's not a huge indicator. But then you have this period, which was just a couple of months prior to their default. Then you have, you know, a zigzag, which means that basically they either don't have enough money to repay the loan, and then they pay what they can, then they pay the next month a little bit more to plug the hole. So you can see some irregularities. Just couple of indicators more. So these are what we really like to look at round payments. Round payments significantly increased in a couple of months prior to the default, which means that this does not have to mean anything, but from our experience, we know that when they start paying, 100,000, 50,000, 150,000, this can be actually a really good indicator that they are paying as much as they can. And finally, factoring transactions. So this is the usage of our services. They did not have any prior factoring transaction. Essentially, any company that has a steady cash flow and healthy cash flow does not have a need for factoring. And then in, April of the year that they defaulted, they, start using a lot of it. This is also a very big indicator. And this is kind of like a summarization. So you can see that essentially these are their buyers. So dynamics with their buyers, beginning of 2022, they basically did not have any activity, they did not receive any money. And when what we later found out is that this company actually lost their biggest buyer. So everybody failed in this case, right? And this is all great if you move client by client, if you develop a tool solely based on what you already know that triggers the defaults. But the question is how you make it more scalable, how you make it more attractive for much bigger players. And the answer is you need more data. But it's very hard to get a hold of data that's representing these companies' transactions, right? So we worked, I think, aside from our core business, we spent the last year working on this. Essentially, we got to a point where we signed a contract with, I can't name names, but with one very big data provider that essentially got us access to around 10 terabytes of data. These are purely transactional data between many thousands of companies. And this opens up a whole new world of possibilities now, right? And a very important thing is that this is multi-source data, which means that if you are examining one company, the transactions that you look at are not only for let's say, if they have accounts with multiple banks, you are going to see at least a couple of those accounts. So you're not going to see only one account, one bank account. Of course, everything is anonymized. All the rules are complied with. But essentially it provides you with, a playing field that you can experiment with and you can create much more interesting stuff. So I'm not sure how technical you are, but this of course creates a very different architecture. I wanted to show you just, how it essentially works. So you have this data provider and their environment, which generates this raw transactional data. Then you have an anonymization algorithm where you basically transform this data, store it in a separate database to which the developers have access to. Then if you want to really optimize things, then you move and to the point of my colleague that had the previous discussion about cloud. It's getting more expensive, but it's much easier to develop in the cloud. But this is a discussion that you can have basically non-stop. So you move the data to the cloud, then you have various different machines that you have below, depending on your use case and what you're building, what you're training. So usually you would have some high memory virtual machine that will serve for pre-processing and cleaning the data, and then dedicated machines for whatever model you're building. The results of the model are stored temporarily again in the cloud, AWS, and then moved to our environment where they're incorporated in the app. I'm not sure if you can see actually, but this is essentially the moment of incorporation of the model weights into the app, and then you generate the app artifact, which is then deployed. You can expand on this infrastructure as much as you want, but this is just a rough outline of how things work. And much more importantly is what this big data set enables you. So enables you to have enriched heuristics, what we call it. So you can now see new patterns that you couldn't see before because you have access to a much wider set of data. You can inspect a full history of a given company, drill down, you know, by date, by year, whatever you want to do. You can, of course, build machine learning models for different cases. So we are focusing on default prediction, but you can also build sales recommendation ML model, which essentially would provide you with an information of when's the good time to lend to this company that you're observing. And my personal favorite, you can build the graph database. So when you have this type of data set, you can essentially create a graph database that represents the interactions in the network. And this is very, very useful when you're when you don't have enough data on the person or the company that you're analyzing. So then you can fall back to, you know, second or third person in the chain and see how they're performing and see that they're maybe extremely dependent on that third node down the line, which can tell you a lot about the company that you're analyzing. So for the end user, we now introduced these things we call dimensions and alerts. Dimensions are essentially ways of looking at the transactional data. So for example, I want to focus now, think of categories actually. So I want to focus now on salaries, or I want to focus now on tax payments or utility payments or whatever you want to create out of the raw data that you have. Then you have alerts, which are essentially the alerts are built on based on dimensions that you create or the model creates. And then you have alerts that are also generated by the model or by yourself. So you can say, okay, I want to be triggered whenever this company misses a payment to their employee, for example. I don't know. So it roughly looks like this. Yeah, I forgot to mention that we also introduced this coverage score. So if you don't have access to, if you're looking at the company and you don't have access to all of their data, which you would know, then you can create this coverage score and say, okay, I'm providing you with a score, but be careful because we did not see all of the data. This is essentially what it tells you. And I'm not sure how clear this is, so here you can see these alerts which are triggered. For example, these are tax filing delay alert, which are triggered by, which are comprised of a dimension called tax repayments. You know, you get the picture basically. And of course you can, we created this overview or report that can be easily interpreted by a non-technical person or somebody that's, you know, much higher in the organizational chart. And alerts provide you with a deeper dive. We found that the analyst actually likes to look at it that way, okay, and inspect basically what part of you know, this company's lifetime triggered this. So you can see, for example, in May, these were a couple of alerts were triggered, and I want to inspect them further. So now you can set this to automatic, or you can create them manually. But basically, you have a much bigger, much better insight into daily life and their daily financial health of the company. And of course, this is going to come in the next months. And the GraphDB, which will, I think by Data Science Conference next year, we'll be able to share it. So the biggest challenges so far, so I put here detailed categorization. So this is not much of a problem in Serbia because we have already data, transactional data categorized in a sense because you have these payment codes. So you essentially know roughly what is the origin, what is the purpose of payment. But if you were to move to any other market, you essentially do not have that, which Serbian data can actually help you in a sense that these transactions are already kind of categorized for you, so you can map that to data from abroad, but this is another discussion. But essentially, if you want to categorize the data, the transactions, you know, much more deeper level, then you need to employ different algorithms for that. You cannot infer that solely based on payment code. The second one is because you have a lot of data, of course, performance. But what I mean by performance here is not, you know, training performance and things like that, but performance in the in the daily usage. So imagine you have terabytes of data sitting somewhere, and then you give an option to your client, to the analyst, to basically inspect some transaction that happened 3 years ago between this client and their counterparty that's not even alive anymore. So you need to really optimize this workflow in terms of accessing the data and what you show to the end user. And maybe the biggest one is to actually explain to the analysts that they can now how they should look at this analysis. So we change the paradigm in terms of what they look for when they analyze a company. This is where I would stop. Thank you for your patience. I would like to answer any of your questions, and we are also hiring data scientists and ML engineers for this project, so if somebody want to talk to me.
Any questions right there?
Many thanks for your talk. I have been actually doing this in my company. So my question is rather technical. How fast can you calculate the reference data? You said it's near real time, so I guess you are calculating on the background daily. And how fast does it run? Does it run for the 200 clients that you mentioned, or for your entire database?
Well, this actually does not have a direct connection with our 200 clients. This is a separate software that's deployed in a bank. So if you, to give you an analogy, so if a bank analyst is looking at a company and they want to see, okay, I want to inspect company ABC, then their data is updated basically in real time, which is essentially maybe 10 minutes delay, because the data is updated constantly by the things that they generate. You know, they initiate these transactions, and these transactions are in real time stored at a database that our software has access to. So there is maybe a 10-minute delay in terms of how we decide to prioritize the data inflow to the platform.
But if you want to do the default scoring, so to assess potential default, then you would need to aggregate the transactions of past X time period.
What do you mean? Yeah, I mean, if you were to analyze a company that's previously unseen, right?
I mean, okay, maybe I can talk to you afterwards about it, but essentially my question is, if you have like a machine learning model that is trying to predict the default in the next X amount of months, and then you are calculating the transactional features in a rolling window in the past, it means that always you have to calculate this rolling window. So how fast do you do that, if you do it?
Well, currently this is still not in production, so I don't have an answer for you for that, but we can stay in touch, and as soon as this is deployed, I can share this information with you.
Thank you.
I have 2 more questions, I guess.
Thank you for your interesting presentation. You say that you are using data from the balance sheet, but also transaction data. No?
Only transactional data for this software. Yeah.
Okay, perfect.
Thank you. I have 2 questions. First, what kind of ML models do you use for predicting the default rate? And second, how you leverage this second graph that you made from the old connections from the transactional data? Do you use some indicators from the graph theory, or what kind of usage do you basically have from the graph? Thanks.
So both of these things are in development now, because we just recently, a couple of months, we got access to it. So, but we're focusing now on the default prediction. This is a probability of default that we are now exploring many different models, basically, to provide us with the probability that the company is going to go bust in the next 6 months. So we have regression models. We are experimenting with XGBoost and some models alike in this domain. And regarding graph, sorry.
Yes, I just wanted to basically. So is it like more traditional ML? It's like a logistic regression, XGBoost, something like that, or do you use the neural network and something like that?
So far, we haven't been experimenting with the neural networks, but we're definitely going to. So this is kind of like this has enabled us now to play around with many different things. So we're just starting with the I don't want to say basics, but obvious things. And regarding GraphDB that we are building, so time's up. But what we have in mind is to create a graph that would basically, each node would be scored, would have an information about one or of many different models that we have in place. So if you were to analyze 6th node from the one that you're looking at, you would see that their score is X, and their probability to default to go bust is 30%, and then you would propagate it to the node that you are currently observing.
Okay, thank you.
But this is still very much work in progress. So we got this, I want to say, easy part already figured out, and the infrastructure is there. But now comes the real stuff.
Thank you, Jovan, for the presentation. I think what you're doing is absolutely brilliant. Absolutely brilliant. Like, I don't even know how you came up with the idea. Immediately when you started the presentation...
We paid for it.
You what?
We had a default, so...
Really? Okay, so... the hardest lessons. Anyway, so what is... I didn't understand correctly. I don't know if I was listening or not, but what is the business model? Are you selling this to the banks?
Yeah.
Or are you selling a whole system that anyone can use?
So far to the banks. We
banks.
are now talking with the banks as of now.
Do you have any clients?
Maybe. Not yet.
Not yet. Are you a startup?
Well, we are not a startup in the sense of our lending business. So we are here for almost 4 years, full 4 years.
Okay.
So we have a lot of experience in the domain. But
Okay.
with this product, this is a fresh product that we are developing.
Well, I will not ask any more questions just to not take any more time. We can meet later and discuss. Thank you.
Thank you.